describing and graphing transformations. So once again, all of this is a review. You learned this all in Algebra 2, but you probably forgot some of it. So I'm going to re-jog your memory on a couple of things. We're going to start with just identifying and graphing. So we're going to just do examples because we've already taken notes on this last year. So identify the parent function. And describe how the graphs are related. Then graph. So one thing that's going to be problematic is you not reading instructions because you have done this before, so you might accidentally just look at the equation I give you and assume you know what I'm asking. So be careful. I want you in this example to identify the parent and describe. I don't just want you to graph, and that's a very common mistake. So then you lose a bunch of points for not forgetting or for forgetting your transformations and the parent. So let's just do one example. Let's do g of x equals the square root of negative 2x plus 6 minus 2. I hope when you look at this, some triggers are going off, because remember, this is a horizontal dilation, and it's not a horizontal dilation by 2, but we'll talk about that in a second. But please remember your parent equations from last year, and in our parent equations we learned that it's x minus h, not bx minus h. So basically what I'm saying is you need to factor this out. And the reason being, I guess you don't have to, but I would. And then this 6 becomes minus 3. So the reason you should factor this out is because now we can actually see what the translation is. This is going right 3, and up here you may have thought it was going left 6, but that's because of the dilation and reflection. So either do it in your head, but I really recommend writing it out just to make sure you don't make any silly mistakes. So that step's not required, but now let's go through the instructions. Identify the parent function. So the parent is going to be f of x equals the square root of x, because this is the square root function. And then for transformations, we've got a negative inside with our x values, so that is a reflection over the y-axis, right? Because if we reflect over the y-axis, then our x values are what are affected. Okay, this too is a horizontal dilation by, and then remember from last year, everything inside with those x values is the opposite of what you would think. So because this is multiplying, it's actually going to be the reciprocal. So it's a horizontal dilation by 1/2, and then we've got a translation, and remember it's the opposite, so if it's minus 3, that means we're going right 3. And we have a translation down 2. Okay, so remember when you're listing your transformations, you need to use the important vocab, reflection, horizontal dilation, and translation. I do not want to see HD. I do not want to see flip. I do not want to say move. You need to write it all out. Okay, now that we've got all of this, we can graph. Now, I always recommend to make a table with the parent and extend it. I always do this. So the parent here for the square root starts at 0, and then we do our first couple perfect squares, the square root of 1 and then the square root of 4. You could also do the square root of 9, but it makes the graph really big, so I'm okay with just 3 key points. So as we said, it's y equals the square root of x. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. So then the next step is to extend your table and apply the transformations. So if it's a reflection over the y-axis, that makes our x values negative. But we also have a horizontal dilation by 1/2, so it's going to be negative 1/2 x. We're going right 3, so that's plus 3. And then down 2, so it's y minus 2. And then we just substitute, so 0 times negative 1/2 plus 3. 1 times negative 1/2 plus 3. Because we're graphing, you could just leave this as 2.5. 4 times negative 1/2 plus 3. And then our y values, so 0 minus 2, 1 minus 2, and 2 minus 2. And then these are the key points I'm going to plot. Now the nice thing about the table is not only do I know my 3 key points so I can do it accurately, and if I, for whatever reason, graph it wrong, this is a little safety net to help me get some partial credit on a test or a quiz. But now I also know how big to make my coordinate plane, and we actually don't need to make it too big. So our x values need to go up to 3, our y values need to go down to negative 2. I always like to go a little bit further, and you should always include the origin. So negative 1, negative 2, negative 3, and then x values 1, 2, 3, I'm going to go to 4, and to negative 1. Because I didn't change my scale, it's okay to not label your scale. If nothing's labeled, I'm going to assume your scale is 1, so if you change your scale, you need to label it, and everything needs to be plotted accurately. Okay, so now I plot my points, so negative 3, negative 2, 3, negative 2, 2.5, negative 1, so 1, 2.5, negative 1, 1, 0. Okay, so we're going to start here, and remember it's curved, and it goes on infinitely, so we need an arrow. And that is it. So let's do an example now of given a graph, what is the equation? So write the equation for g of x. Well, we already used g of x. Let's use h of x. Write the equation for h of x. Okay, so for your coordinate plane, let's go up to positive 1 and down to negative 12. And I'm going to actually count to negative 12, I think. Yeah. Alright, so negative 1, 2, 3, 4. Yeah, I've got room for it. And then for x values, let's go to negative 6. And positive 2. And I guess I should let my dog in. Wasn't. So luckily I haven't done much except for graph it. So maybe pause the video. I want you to graph your vertical asymptote at x equals negative 2, a horizontal asymptote at y equals negative 5, and then plot the point negative 1, negative 2, and negative 3, negative 8. I recommend anytime you're given a graph and you want to write the equation, I always recommend identifying the parent, and list your transformations. Or at least translations. Okay. What's required it's required that you substitute what you know into the generalized equation, and then it's also required that you algebraically, and this is where a bunch of you are going to lose points because you're not going to do this, solve for vertical dilations only. And reflections. So we say vertical dilations because all dilations can be written as just a vertical dilation. So up here, this doesn't have to be a horizontal dilation. We could rewrite this as just a vertical dilation. So that's what we're going to do here, and you need to show it. So this is required. You will not get full credit if you do it all on your own. So my recommendation, I'm going to start there. I'm going to write the parent. So this is the reciprocal function. So this is 1 over x is the parent. And then if I'm looking at my graph, remember for reciprocal functions, you know the translations based on the asymptotes, because the asymptotes are normally at 0 and y equals 0. So I know that this is being translated left 5 and, or did I say left? Sorry, down 5 down 5 and left 2. And if you remember from Algebra 2, that means that our equation so far is g of x equals, I don't know if I have a dilation, so I'm just going to put an a up there, x, this is where my horizontal translations go, so it's x plus 2, and then minus 5 is on the outside. Not in the numerator, it's on the outside. So now I'm going to algebraically solve for a vertical dilation by taking a point I know, and I've only given you 2, so those are your 2 options, substituting it in here and solving for a. So let's do the, I'm going to do the -1, -2. So I'm going to add 5 to both sides, so that's 3 equals a divided by a -1 plus 2 is just 1. So my vertical dilation is by 3. So this is required. And then your final equation. So my final equation, and I forgot that we renamed this h of x, so I should fix this, is going to be 3 over x plus 2 minus 5. And I'm going to repeat this one more time. Please remember the requirements. So you have to show your algebra. You have to show substituting this in and getting your a value and then rewriting your equation. That's what's required.